So in the last lecture, we had discussed this topic, three types of relation, okay? Reflexive, symmetric, transitive, then after anti-symmetric case in yesterday's lecture, okay? We had discussed this point. And after that, we had defined one relation that is called equivalence relation, okay? And we had discussed one of its example in this yesterday's lecture, okay? So what is meaning of equivalence relation? If it is satisfy the reflexive condition, symmetric condition, and the transitive condition, we can say this R, okay, is called the equivalence relation. Clear? And here the condition is given that what is meaning of reflexive, that is the symmetric, and that is the transitive. Okay, reflexive means for every element, for every A belongs to A, the A comma A should belongs to the relation that. Clear? And then after symmetric, if AB belongs to the R, this implies B comma A should also belongs to the R. That is called symmetric condition. And third one is transitive. Okay, for AB and the BC, if it is belongs to the R, this implies A comma C that also be in this R. Clear? Should also be in this R. So it is called the transitive condition. If it is satisfy all these three conditions, then we can say this type of relation is called the equivalence relation. Okay. And in this last lecture, we had discussed this example here. Directly one subset is given that for A is equal to 1, 2, 3, 4. And you just verify it is reflexive, symmetric, and transitive or not. If all these three condition is verified, then we can say it is the equivalence relation. Okay. So here first pair 1 comma 1, that is 2 comma 2, 3 comma 3, 4 comma 4. So for every element of the A, the pair A comma A should exist here. Okay, and it is given, so it is the symmetric reflexive. And then after symmetric form, so 1 comma 2 के लिए 2 comma 1 यहाँ पे exist कर रहा है. Then after 3 comma 4, 4 comma 3 is exist here, and this pair as a 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 is by default symmetric as well as anti-symmetric form. Okay, so this is a symmetric relation. And then after the transitive, so just consider such pair as a 1 2. Okay, and then after 2 1 as a AB and BC, where B should be the common. Okay, so then after create the A comma C form, means the first entry here and the last entry from the second set. Okay, so this pair should belongs to the relation. Clear? And for all such possibility AB and BC, if it is belongs to the R here, then A comma C is also existed. Okay, so it is the transitive form. Clear? And then after we discuss this example here, the set of integer is given that, and one of its relation is defined here. Okay, for every entry. Okay, for entries AB belongs to the Z, uh, which pair we can include in the relation, which pair, which values of the AB we can include in the relation if it is satisfied A less than or equal to B condition. Okay, so if it is satisfy A less than or equal to B, so this type of value, okay, this type of pair we can include in the relation. Clear? So which possibility will be there in this relation? You can consider 1 comma 2. Okay, that is satisfy A less than or equal to B. Then after 3 comma 4, 3 less than or equal to 4. Okay, 3 comma 3. Clear? 2 comma 2, 5 comma 7. So this all possibility will be there. Okay, there is infinite possibility there because Z is infinite. Clear? Set of integer. So lots of possibility will be there. And now you have to check that this define R. Okay, so define hoga for the values of A and B. If it is reflexive, symmetric, and transitive, then we can say that it is the equivalence relation. Okay. So reflexive के लिए आपको क्या prove करना है? Okay, consider this general form of the relation. Okay, AB belongs to R. So just consider A comma A form. So for A comma A form, when we say it is the R, if it is satisfy A less than or equal to A condition. Clear? And it is a proof in mathematics A less than or equal to A. Equality is there, therefore it is a correct. Okay? If I remove the equality, only strictly less than, therefore it is incorrect for any values of the A. Clear? For any values of the A belongs to the Z. For example, if I write a 5 less than 5, then it is incorrect form. But if I include equality between them, then now it is a correct one. Clear? 5 less than or equal to 5, 7 less than or equal to 7, 9 less than or equal to 9. Clear? So for every values of the A belongs to the Z, A less than or equal to A always satisfy that, and therefore we can say that A comma A, that is belongs to the R. Clear? So therefore it is reflexive. And then after for symmetric, so here for symmetric we just consider if AB belongs to the R, means A less than or equal to B. Clear? So B comma A should also belongs to the R. But here for a less than or equal to b, we cannot write b is also less than or equal to a. Clear? We can't write b less than or equal to a. Clear? So therefore we can say that b comma a does not belongs to the R. Clear? And you can verify also that for any example, you can consider here, let us take 5 and 7 belongs to the R. Clear? Means 5 less than or equal to 7. That is the correct one. Therefore we can say that 5, 7 belongs to the R. But if we interchange this value, okay, let us write 7 less than or equal to 5. So that is incorrect one. Okay? Means we cannot say 7 pi is also belongs to the R. Clear? So it is not true that. So therefore it is not a symmetric relation. Clear? And now for transitive one. So for transitive, we can easily say that if a less than or equal to b means ab belongs to R, b less than or equal to c means bc belongs to R. So now observe this condition that a less than b hai, b less than c hai. Then we can write a is also less than or equal to c. Clear? It is obvious result, and you can consider this counter example for this one. If we write 5 less than or equal to 6, okay, that is ab, and 6 less than or equal to 10. Clear? That is the BC. B is a common here. Okay, so we can easily say that 5 is also less than or equal to 10. Clear? So it is true for any AB, BC, and we can easily say that A comma C is also belongs to the R there. So it is proved the transitive relation. And here one of the condition is not proved here. Okay, the symmetric condition. So therefore we can say that it is not an equivalence relation. Clear? If all the three condition is proved, then we can say it is equivalence relation. Clear? If any of this condition, if it is not a proof for any value, then it is not a equivalence relation. Okay. And then after another one example is there. It is involve the congruence modulo. So what is meaning of congruence modulo? Okay, for a given positive integer n greater than equal to 2. Okay. For given positive integer n greater than equal to 2, two integer a and b. Two integer a and b are called congruent modulo n, and that is written as a congruent modulo b, a b mod n. Clear? And what does it mean? If a minus b divisible by n. Okay? A minus b ka difference, it should be divisible by n. Clear? So therefore we can say that it is the congruent modulo n. And here it's one example is given that to prove that congruence modulo n is an equivalence relation. Okay? Congruence modulo n is an equivalence relation. Clear? So what does it mean? Okay, for on the z is given that for every AB belongs to z. Okay, which type of relation is given here? Okay, for every AB belongs to the z, AB belongs to the R. When we say AB belongs to the R, okay, if A congruent modulo B mod n. Okay, A congruent B mod n. Okay, if it is a true, then we can say that this AB belongs to the R. Means when we say it is a true, if difference of A minus B, okay, A minus B should be the divisible by n. Okay, then we can say that this pair AB belongs to the R. So here we'll consider for the Z, okay, set of integer. And now let us check it reflexivity condition, reflexive condition. So what does it mean? Okay, here we consider for reflexivity, for every A belongs to Z. For every A belongs to Z, you have to check that A comma A belongs to the R. Clear? So what is meaning of A comma A belongs to R? Okay, for AB belongs to R, if A congruent B modulo n. Okay? A congruent B modulo n. When we say AB belongs to R, if A congruent B modulo n. Okay? In this previous example, we have condition is A less than or equal to B. Okay? Now in place of that, we have A congruent B modulo n. Okay? That is the condition is given that. And what is meaning of congruent modulo n? A difference of A minus B. Okay, A minus B, it should be divisible by n. Then we can say that A congruent B modulo n. Okay, that is meaning. And here we consider A belongs to Z. A belongs to Z. And we have A congruent A mod n because A minus A is equal to 0 and 0 is divisible by n. Okay, and hence it is the reflexive relation. Okay, let us check it. Okay. A B belongs to R. Okay, that we have A congruent B mod n. Okay, and now we have to check that A comma A. Okay, and it will be A congruent A mod n. Okay, in place of B we just consider A there. And what is meaning of A congruent A mod n? So it will be the A minus A. Okay, A minus B is divisible by n if A congruent be mod n. Clear? So right now here A congruent A mod n, so it will be the A minus A is equal to 0, and 0 is the divisible by n. Okay, mod n means n is any values there. So n is divisible by the n. Okay, so 0 is divisible by n. Okay, so it is a correct form. So we can say that it is the reflexive relation. Now you can consider any number that from the z, let us take 2 congruent to mod n. Okay, so 2 minus 2, 0. 0 is divisible by n. Okay, 3 congruent 3 mod n, minus 1 congruent minus 1 mod n. Any number you can consider from the z, and it will be the valid form in the reflexive condition. Okay, so reflexivity is correct. And now the symmetric form. So in the symmetric form, you have to consider if AB belongs to R. ठीक है, अगर AB R में है तो when we say it is a symmetric, B A B R में होना चाहिए. ठीक है, that is meaning of symmetric condition. So for symmetricity, let us consider AB belongs to R. Okay, let us consider AB belongs to R. So what does it mean? A congruent B mod n. Okay, so what is meaning of A congruent B mod n? It will be A minus B is divisible by n. Okay, A minus B is divisible by n. So what is meaning of that? When we say for example, if I consider 6 is divisible by 3. Okay, 6 is divisible by 3. So what does it mean? Okay, we can consider 6 as a 3 into 2. Okay, the factor form. Here that is the n. So here I can consider A minus B is divisible by n. Okay, A minus B is divisible by n. So it will be right as A minus B divided by n is equal to the k. Okay, or A minus B Okay, so let's start it. Sorry for the disturbance. A minus B is divisible by n. So how we can write this form as a A minus B divided by n is equal to k. How we can define this k here? For example, if I consider 6 is divisible by 3. Okay, 6 is divisible by 3 means 6 by 3, and 6 by 3 is equal to the 2. Clear? 2 meaning, what is meaning of this 2? That is called the k. Clear? 6 is divisible by 3 means in place of 6 we have A minus B. Clear? A minus B is divisible by n. So what does it mean? When we divide A minus B by n, we'll get one answer. Okay, and that is called the k. Clear? So A minus B divided by n is equal to the k, and for some k belongs to z. Okay, this k will be from the z. It may be either negative, otherwise a positive, otherwise sometime it will be the 0. Okay, so k belongs to z. So what does it mean? A minus B is equal to the nk. Clear? A minus B is equal to the nk. In this form we have A minus B divided by n is equal to the k. So what does it mean? You can write A minus B is equal to nk. Clear? For some k belongs to the z, and therefore if we interchange this two digit, okay, means A minus B as a B minus A minus B as a B minus A. So what does it mean? Okay, that will be right as a B minus A is equal to the minus of A minus B. Clear? B minus A can be defined as a minus of A minus B. Clear? Just apply minus to this bracket, we'll again get a b minus a form. So it will be the minus of nk, because a minus b kya hai, that is a nk. Clear? So it will be right as a n of minus k. Clear? N of minus k. And as you know that k belongs to z, so minus k also belongs to the z there. Clear? So therefore we can write b minus a divided by n is equal to minus k, and so we can say that b minus a is also divisible by n, and for the result minus k belongs to the z. Okay, b minus a also belongs to the z, for minus k belongs to the z. Clear? And therefore we can say that b congruent a mod n. Clear? And as you know the k belongs to z है, तो minus k also belongs to the z there. ठीक है, अगर 2 belongs to z है, so minus 2 also will exist in the z there. Clear? So it is a correct for any number. So b minus a is also divisible by n. Okay, and therefore we can say that b congruent a mod n. Clear? And that is our required result. When we say b congruent a mod n, if ba belongs to the r, then we can say that b congruent a mod n. Clear? So symmetric prove हो गया, ab belongs to r से हमने start किया था. ठीक है, and at last we derive one result, BA is also belongs to the R there. Okay? So therefore we can say that this relation is called the symmetric relation also. Clear? This type of relation is also the symmetric relation. And the third one, that is the transitivity, means a transitive relation. So उसके लिए आपको क्या consider करना है कि दो pair define करनी है, that should be in this R. AB belongs to R and the BC belongs to R. So when we say AB belongs to R, A congruent B mod n. ठीक है, and when we say BC belongs to R, B congruent C mod n. ठीक है, and what is meaning of this one, A congruent B mod n? A minus B is divisible by n. ठीक है, so we can write A minus B is divisible by n as a minus B divided by n is equal to the k. ठीक है, that is evolution of first form. And here b minus b congruent C mod n means b minus C is divisible by n. So what does it mean? Okay, b minus C divided by n. Let us take another value, another notations for this one. Let us say it is the L. Okay, so b minus C divided by n is equal to the L for some KL belongs to the Z. Okay, for some arbitrary KL belongs to the Z. So a minus b divided by n is equal to k. So it can be right as a minus b is equal to nk. And second is a b minus c divided by n is equal to the L. So it will be right as a b minus c is equal to nl. Okay, for KL belongs to the Z. So now we have to derive that a comma c belongs to the R. Okay, आपको prove क्या करना है कि AC is also belongs to the R there. ठीक है, AC भी R के अंदर होना चाहिए, ये आपको prove करना है. So how we can define the a comma c form? So observe this left hand side part of this one, a minus b, and here it is a b minus c, and we need a minus c form by using this both the equation. Okay, so just we add this both equation. Okay, so in this we'll get a minus b plus b minus c is equal to the nk plus nl. Okay, you will get this form, a minus b plus b minus c is equal to the nk plus nl. You'll just add this both equation. Okay, so after that we'll get a minus c form here, because minus b plus b will be removed. Clear? So we'll get a minus c is equal to the, take n as a common, so it will be the k plus l. Okay, it will be the k plus l. So what we derived here, a minus c divided by n is equal to the k plus l. Okay, and now we know that k is belongs to z, l is also belongs to z. So when we add this both value k plus l, that also will be in the z that. ठीक है, आप कोई भी counter example उसके लिए ले सकते हो. Let's take 2 belongs to z as a k and 3 belongs to z as a l. So just now add this both value, 2 plus 3 is equal to the 5, and we can easily say that 5 is also contained in the z. Okay, so we just derive that k minus c divided by n is equal to the k plus l. So what does it mean? K a congruent c, okay, mod n. Okay, we can say that a congruent c mod n. Clear? So a minus c is divisible by n, as a k plus l is also belongs to the z that, and it means a congruent c mod n. That is a proved. And by using the AB belongs to R, BC belongs to R, here we derive AC is also belongs to the R that. Okay, AC is also belongs to the R, and therefore it is the transitive relation, and therefore we can say that this is the equivalence relation on the Z. Okay, why it is equivalence relation? Because it satisfies reflexive condition, symmetric condition, okay, and at last we had proved the transitive condition, okay, transitive condition. So all these three condition is proved for this example. So we can say it is the equivalence relation on Z. Is it clear? समझ में आ गया सबको ये एग्जांपल? Is there any doubt, any query? Hello, is it clear to all? Have you any query, any doubt? क्या समझ में नहीं है आपको राज?
और सिमेट्रिक कैसे हुआ वो एक बार?
कौन सा?
सिमेट्रिक
सिमेट्रिक वाला, ओके. सो इन दिस सिमेट्रिक रिलेशंस आपको प्रूव क्या करना है, ठीक है? आपको कंसिडर करना है फर्स्ट ए बी बिलोंग्स टू आर. इससे आपको स्टार्ट करना है आपका एग्जाम्पल, ठीक है? और बाय यूजिंग रूल्स ऑफ मैथमेटिक्स आपको प्रूव करना है कि बी ए भी आर के अंदर है, ठीक है? उसका सिमेट्रिक फॉर्म की आर के अंदर होना चाहिए, आपको प्रूव करना है, ठीक है? तो हमारे पास कंडीशन क्या है रिलेशन की? व्हेन वी से ए बी बिलोंग्स टू आर, ओके, सो इफ ए congruent बी mod n, A congruent be mod n. So what is meaning of A congruent be mod n? If A minus B is divisible by n, ठीक है, उसका जो डिफरेंस है वो n से डिवाइड होना चाहिए. That is the condition of congruent modulo n, ठीक है? So here we consider AB belongs to R. इससे हमने स्टार्ट किया अपना एग्जाम्पल. लेट्स टेक AB R के अंदर है, ठीक है? एक कोई पेयर है, कोई दो नंबर है जो R में है. So what is meaning of that? Here we can prove that A congruent be mod n, ठीक है? So what does it mean? तो उसका जो डिफरेंस है, उसका जो डिफरेंस होगा इट्स विल शुड बी द डिविजिबल बाय n, ठीक है? इट विल बी द डिविजिबल बाय n. सो a minus b is divisible by n. so what is meaning of the divisible by n, ठीक है? so we can define as a by this example, okay? Why we consider here k is our answer, okay? When we divide a minus b by n, you will get one answer. For example, divide let us take here 12 minus 6, okay, as a and b. A मेरा a है, a b है, ठीक है? And this is a mod 3, okay? Here I consider n value, that is the 3. Clear? So a minus b is divisible by 3. A is a 12, b is a 6, and mod n means n is equal to 3. So 12 minus 6 is divisible by 3. So 12 minus 6 is divisible by 3. So check that. So 12 minus 6 will be 6. 6 divisible by 3. So it will be the 2 that. Clear? So 2 means this is the values of the k. Clear? 2 means this is the values of the k. So here we can write that a minus b is divisible by n means a minus b divided by n is equal to the k. When we divide this a minus b form by n, okay, so you will get one answer that is called the k. Clear? And this k will be from the z, ठीक है? और जो आंसर होगा वो z के अंदर डिफाइन होगा, का तो आपको नेगेटिव वैल्यू मिलेगी, अदरवाइज इट विल बी द पॉजिटिव फॉर्म, ठीक है? And therefore we can write that a minus b divided by n is equal to k, means a minus b is equal to nk. A minus b is equal to nk, okay? So now we need a b minus a form, okay? कि आपने यहाँ पे प्रूव किया है कि 12 minus 6 is divisible by 3 है, so just interchange 12 and 6, okay? So it will be the 6 minus 12. यहाँ पे क्या मिलेगा आपको? 6 minus 12. And now check that it divisible by 6 or not, okay? So 12 minus 6 divisible by 3 है, that is the correct one. So now we consider 6 minus 12. 6 minus 12 is divisible by 3 or not, okay? So it is also correct. That will be the minus 6 you will get, okay? Divide by 3 and you will get a minus 2. Clear? So here I use this form here. Okay, b minus a, it will be right as a minus of a minus b, and minus of a minus b means minus nk. Okay, so a minus b kya hai, that is nk, and that will be right n of minus k. Clear? So it will be right as a b minus a divided by n is equal to the minus k. Clear? You will get a minus k answer when we divide b minus a divided by n. And as we know that अगर k z में है, ठीक है, k की वैल्यू z में है, तो माइनस के ऑल्सो एग्जिस्ट इन द z, ठीक है? अगर के कोई भी आप नंबर ले लो के की वैल्यू, ठीक है, अगर वो z के अंदर है तो माइनस के उसको आप माइनस अप्लाई कर दो तो वो भी z के अंदर आएगी, क्योंकि z इज द सेट ऑफ इंटीजर, ओके? it will contain negative as well as positive both. ठीक है, तो minus k also count in the z. ठीक है, so therefore we can say that b minus a is divisible by n as a minus k belongs to z, and therefore we can write b congruent a mod n. ठीक है, b minus a is divisible by n means b congruent a mod n, and what does it mean? ba belongs to the r. Clear? And that is required to say it is a symmetric relation. क्लियर? सो ए बी से हमने स्टार्ट किया था और बी ए पे हमने कंप्लीट किया. ठीक है, ए बी बिलोंग्स टू आर है तो बी ए भी आर के अंदर होना चाहिए. दैट इज द फॉर्म. ओके, गुड. सो आफ्टर दैट next example is there, that is another example, x r y. okay, here a set is also from the z. ठीक है, x y की वैल्यू आपको z में से कंसीडर करनी है और रिलेशन क्या है कि x y belongs to the z, and when we say it is the relation xy belongs to r if xy greater than equal to 0. ठीक है, उसका जो प्रोडक्ट है वो 0 से बड़ी वैल्यू होनी चाहिए. ठीक है, so this pair you can include in the relation, and there are lots of possibility that you can consider 1 2, okay, 2 3, clear, 2 0 1 0 1 1. this all will be the pair in this relation. that clear, उसका जो प्रोडक्ट है 1 into 2 there will be 2 greater than 0, 2 into 3 2 into 0, 1 into 1. okay, so this type of pair you can include that. clear, but you cannot include here 1 comma minus 1. ठीक है, सो प्रोडक्ट क्या होगा इसका -1 होगा और -1 ग्रेटर देन 0, दैट इज इनकरेक्ट. ठीक है, तो देयरफॉर वी कैन नॉट इंक्लूड दिस टाइप ऑफ पेयर जिसमें एक वैल्यू नेगेटिव हो, बट वी कैन इंक्लूड दिस पेयर -2 -1. उसका प्रोडक्ट पॉजिटिव होगा, -2 into -1 that will be the +2 that, and +2 greater than equal to 0. ठीक है, so this type of pair we can include in this relation, but now you have to observe, you have to check that is equivalence relation or not. okay, so first conditions में आपको चेक करना है रिफ्लेक्सिव, सेकंड में आपको चेक करना है सिमेट्रिक. ओके, एंड इन द थर्ड कंडीशंस विल चेक द ट्रांजिटिव कंडीशन. क्लियर? सो रिफ्लेक्सिव, so in reflexive you have to consider x comma y belongs to r if x into x greater than equal to 0. okay, x into x, तो प्रोडक्ट है x into y that is greater than equal to 0 here, so in place of y आपको पुट करना है x. ठीक है, और आपको कंडीशन चेक करनी है ग्रेटर देन इक्वल टू 0 डिफाइन होता है या नहीं. ठीक है, तो x into x, कोई भी x आप z में से चूज करो. ठीक है, एनी वैल्यू यू कैन कंसीडर फ्रॉम द z, सो x into x विल बी द x स्क्वायर. ठीक है, और कोई भी x आप कंसीडर करो z में से तो x स्क्वायर होगा दैट इज ऑलवेज ग्रेटर देन इक्वल टू z. कोई भी आप नेगेटिव नंबर यूज करो, पॉजिटिव 0 यूज करो. ठीक है, सो फॉर एवरी x बिलोंग्स टू द z, उसका जो x स्क्वायर होगा, ठीक है, उसका जो पावर होगा दैट इज ऑलवेज ग्रेटर देन इक्वल टू 0. ठीक है, ऑलवेज ग्रेटर देन इक्वल टू 0. व्हाई इट इज ग्रेटर देन इक्वल टू 0? लेट अस टेक नेगेटिव वैल्यू -5. ओके, सो x स्क्वायर क्या होगा 25 होगा, एंड 25 ग्रेटर देन इक्वल टू 0. दैट क्लियर? लेट अस टेक x इज इक्वल टू 7. so 7 square will be the 49, and 49 greater than equal to 0. so for every number z की सभी वैल्यू के लिए, ठीक है, x comma x always belongs to the relation. ठीक है, so it is reflexive relation on the z. ठीक है, and then after for a symmetric relation, so for symmetric relations you have to check here xy belongs to r है तो y x भी r के अंदर होना चाहिए. ठीक है, so here we start xry, so xry means xy belongs to r, then x greater than equal to y, xy greater than equal to 0. ठीक है, so xy greater than equal to 0 है, now just interchange the number, so we can easily say that y x is also greater than equal to 0. ठीक है, y x भी 0 से बड़ी वैल्यू होगी, y into x का प्रोडक्ट. फॉर एग्जांपल 2 into let us take 5. okay, 2 into 5 means is equal to 10, 10 greater than equal to 0. ठीक है, now interchange that 5 into 2, so 5 into 2 is also a 10, and that is also greater than equal to 0. Okay, just wait for the 2 minute. Just some work, and after 2 minutes we'll start this lecture again. Okay, just wait for 2 minutes. ओके, सॉरी फॉर द डिस्टर्बेंस। तो आज जो एमयू का पेपर है ना, तो कुछ बच्चों को क्वेरी थी। ओके, सो लेट्स स्टार्ट द अगेन। Okay, we discuss this example. xy xry if xy greater than equal to 0. ठीक है, ये एग्जांपल हम डिस्कस कर रहे थे and we had discussed the reflexive, then after symmetric. ठीक है, why it is symmetric relation? क्योंकि you can easily verify that अगर xy greater than equal to 0 है तो yx greater than equal to 0 ही होगा. ठीक है, and therefore we can write that is x means yx belongs to the R. ठीक है, and it is the proof. It is symmetric relation. And now for transitive, if x r y means xy greater than equal to 0, y r x, ठीक है, y r z means yz greater than equal to 0. So can we say xz is also greater than equal to 0? It is a correct form also. Clear? xy greater than equal to 0 है, yz भी greater than equal to 0 है. ठीक है, so we can easily say that xz is also greater than equal to 0. Okay, means here we consider the sign value and so on. xy x and y have the same sign. Okay, product of x and y, and y and z also have the same sign. Then we can easily say that xz also have the same sign. Okay, means for this data, for example, 2 into 5, okay, is greater than equal to 0. 5 into 10, that is also greater than equal to 0. Okay, 2 into 5 and 5 into 10 is greater than equal to 0. So we can easily say that 2 into 10 is also greater than equal to 0. Okay, 2 and 5 have the same sign. Okay, दोनों positive है. 5 and 10 also have the same sign, दोनों positive है. So positive into positive will be the positive again. Okay, will be the positive again. So therefore it is a transitive relation and it will be the xz belongs to the R. Okay, and means xrz, and therefore it is transitive, and thus we can say it is the equivalence relation. Okay, so all these three conditions is proved, and therefore it is the equivalence relation. So now another example, a subset form is given that, and P of A is given here. Okay, for A is equal to ABC, how we can check the P of A? Yes, anyone have idea how we can check the power set of the A? How we can derive power set of the A, P of A? It will be the subset of
B, sir. Subset of B, sir.
the A. Yes. So P of A can be defined as a first is a 5 is the subset of A, and after singleton A is a subset of A, B, C. Okay, and then after pair of two element A, B, then after B, C, and then after C, A. Clear? Otherwise A comma C, and then the A. Clear? So A is also subset of. So collection of all possible subset. Collection of all possible subset of the given set A, that is called P of A. Okay? और यहाँ पे कंडीशन है for the element xy belongs to the P of A. Okay, when we say x comma y belongs to the relation, if x is a subset y, ठीक है, अगर x y का subset है तो we can say that this x and y belongs to the R. ठीक है, means x y की जो पेयर होगी वो रिलेशन में होगी. ठीक है, for example, let us take A as a x and AB as a x and y. Okay, this pair I have considered as a x and as a y. So this is in belongs to the R. Why it is in belongs to the R? Because singleton A is a subset of A comma B. Clear? Singleton A is a subset of A comma B. So therefore it is the value. But if I interchange that, okay, if I consider AB and comma A, okay, AB comma A, so it is not from the relation. Okay, why it is not relation? Because यहाँ पे subset की condition fulfill नहीं हो रही. ठीक है, that is not a true. AB is not a subset of singleton A. Clear? That is not a true. Therefore, A, B, comma A, that is not a part of the relation. Clear? But this type of pair which satisfy the condition X is a subset Y, then this pair we can include in the relation. Okay. So here we have to prove that equivalence relation or not. Okay. So first condition for equivalence relation, that is reflexive. So in reflexive आपको क्या check करना है? So for every X belongs to P of A, every X belongs to P of A, X comma X should be the part of the relation. Okay. So when we say X comma X belongs to R, if x is a subset of x. Okay, x should be the subset of x, and it is a true for every element of the x. Okay, for every element x belongs to B. Okay, for example, सिंगलटन ए है तो इट इज सबसेट ऑफ ए इटसेल्फ. ठीक है, कोई भी सेट है और खुद का तो सबसेट हमेशा होता ही है. ठीक है, एवरी सेट इज अ सबसेट ऑफ इटसेल्फ. ठीक है, सो ए इज अ सबसेट ऑफ ए, then after B is a subset of B, AB is a subset of AB, clear? 5 is a subset of 5, clear? BC is a subset of BC, so it will be true. So X is always subset of X, and therefore it is the reflexive condition. Okay, so it is the reflexive. Second one is the symmetric condition. So in symmetric आपको क्या चेक करना है कि अगर x, y belongs to R है, this implies y x भी R के अंदर होना चाहिए. ठीक है, ये आपको प्रूव करना है. अगर x y R में है तो उसका जो सिमेट्रिक फॉर्म होगा y x, it should be also the part of R. Let us check it for counter example, and you can consider also general idea that अगर x y R में है तो what does it mean? X is a subset of y. Okay, and here if x is a subset y, so it is not true that y is also the subset of x every time. Okay, so y can't a subset of x, and therefore we can say that y x does not belongs to the R. Okay, and for counter example you can consider this one. A singleton a comma ab belongs to R here, means a is a subset ab. So now interchange y and x. Okay, x and y, so it will be ab and the x. Okay, ab comma a. So check that ab subset a, that is not a true. Okay, ab subset a, that is not a true there. So therefore yx does not belongs to the R. Okay, and therefore it is not a symmetric relation. It is not a symmetric relation. Okay, so now let us check the transitive. It is not a symmetric, and we can consider this example here. It is symmetric or not. Okay, so it is not a symmetric. Clear? And now third one is the transitive. So in transitive आपको प्रूव करना है कि xy R में है. ठीक है, xy belongs to R. xy, then after let us consider another pair yz, both R belongs to R. This implies xz भी R के अंदर होना चाहिए. ठीक है, that is the form. So xy belongs to R means this implies x is a subset y. ठीक है, yz belongs to R means y is a subset z. ठीक है, अगर x y का subset है, x is a subset y, y is a subset z, then we can easily say that x is also a subset of z. Clear? That is a simple, and you can consider this example for that one. Let us take a, then after ab, and abc means the a itself. Okay, a itself means abc. These three elements I have considered as a x, y, and the y, z. Okay, where a is a subset ab. Clear? That is x subset y. ab is a subset of a, that is a y subset z. Okay, so what does it mean? We can easily say that a is a subset of a means abc itself. Okay, the three entry will be in abc, that is called a. So a is a subset of ab, that is x subset y is a subset z, y should be the common. Okay, so y I have considered as ab, so ab is a subset of a. Clear? Ab is a subset of a, so we can say that singleton a is a subset a. Okay, singleton a is a subset of a. Clear? So therefore it is the transitive form. Clear? Prove हो गया है कि xz, it is also the part of the relation. Clear? And therefore it is the transitive relation. Okay, so here one of the condition is not proved here, reflexive symmetric condition, so therefore it is not a equivalence relation. Okay, therefore it is not a equivalence relation. Is it clear, this example? Is it clear? Okay, good. And we'll solve some more example related to the equivalence relation in the practice session, means in the lab session. Okay, when we start this assignment number 3. And now in next lecture we'll give up to this. In next lecture we'll start the matrix part again. Okay, in this I think first and second lecture we had discussed the matrix theory, that relations to the matrix. Okay, representation of relations using the matrix. Okay, we'll extend this theory and we'll use now relation form, means reflexive, symmetric, transitive, antisymmetric form, and we'll identify which type of matrix is known as a reflexive matrix. Okay, which type of matrix is called the symmetric matrix, which type of matrix is called the transitive matrix, and so on. Okay, so we'll discuss this type of theory in the next lecture. Okay, and we'll extend this matrix part again, clear, as a relation point of view, clear. And we have 3 to 4 types of relations, so we'll derive the matrix also. Okay, for reflexive, symmetric, transitive, and so clear. So we'll discuss this in the next lecture and we'll keep up to this now.